Dear students, today we are going to discuss about the AC electrical machines. AC electrical machines may be a generator and motor. But in this lecture, we are going to see what are the AC motors are available in the market or in the field of electrical engineering to perform different operations. AC motors means alternating current motor, the motor which is working on the input of the alternating current is called AC motors. In the real-time applications, we are generating the power in the form of AC. We are aware that the alternating current has been generated from the different power plants. Power plants are generating alternating current. The power plant may be a thermal power plant, or it may be a hydro power plant, or it may be nuclear power plants. They all are the conventional power plant. We know non-conventional power plants also available, which are, best example is solar. So solar actually generate in the DC, but the conventional power plants which are used for the huge amount of power generations. So AC motors in our home appliances and industries, we will find the alternating current machines. For example, if you take the fan is having installed the induction motor, it's a AC motor, single phase motor, and grinder, mixie, even for the water pump, they all are the using the AC motor. So the application of AC motor is not a limited one, but it has the huge application. So being the electrical engineer, we need to have the basic knowledge about the AC motors and its application. So in this class we are going to see what are the different type of AC motors are available and how they have been classified. Alternating current, reverse direction. Alternating current, AC motor means the current which is have been alternatively changing its polarity. So in which there are two major parts are available. If you take a induction motor, if you take a AC motor, in which there are two main winding. Any motor, even if you consider the DC motor or AC motor, DC generator or AC generator, they will have the two windings. Two winding is very important to the machine. So electrical machine will have the two winding. One winding is normally called as the stator winding, another one winding is called as a rotor winding. So if you see the DC machine, in which the stator winding and rotor winding will be called by specific name. We could remember that the stator winding is nothing but the field winding in case of DC motor, and the rotor winding is nothing but the armature winding in DC. But when we come to the AC motors or AC alternators, we have the different name for the stator and the rotor. The stator and rotor is represented, or it is called in the AC motors, the stationary part of the machine is called as the stator, and the rotating part of the machine is called as a rotor. So we have specific name stator and rotor in AC motors. The stator is also having the winding and rotor also will have the winding, but the rotor will be the rotating part of the machine and stator will be the stationary part of the machine, but we will have the two winding because all the electrical machine is working based on the electromagnetic induction or Faraday's law. So Faraday's law, if we understand, then only we could understand about the AC motors. I hope everybody is knowing about the Faraday's law. What is Faraday's law? Faraday's law is saying that if the electrical conductor is placed in the magnetic field, so we need to have the magnetic field and conductor. That's why we always require the two windings. One is the stator winding and rotor winding. So according to Faraday's law, if the conductor is placed in the magnetic field and if it's subjected to rotation, there will be EMF induced. That is the generator action. Then what is motor action? So motor action means that current carrying conductor will be placed in the magnetic field. Current carrying conductor will be placed in the magnetic field. So the two fields or flux will be having interaction with each other. by which the torque will be produced in the machine. Due to that, the rotating part of the machine will be rotating. So all the machine will have the two major parts. One is the stator winding, another one is the rotor winding. So stator is stationary one and rotor is rotating one. You can see that this is actual machine outermost surface, and in which this rotor, this is a representation of the rotor, this is a representation of the stator. In the stator we have the coils, in the stator we have the coils. So conductor will be available in stator as well as in the rotor, and this rotor will be fit into this inside. So outer frame, this outer frame is showing the stator portion. Outer frame, inside the outer frame we will have this stator coils, conductors, and in the rotor we will have the inside the rotor we have the conducting parts. They are the rotor conductors, and it will be placed inside the stator. So the stator is outer frame and the rotor will have the inside, and this rotor will have the shaft. This is the shaft of the rotor, which is nothing but the rotating part. So when the shaft of the rotor is rotating, rotor conductor also will be rotating. When it is cutting the flux available in the field, the EMF will be induced in the generator action, and suppose we give supply to this stator and rotor, then the conductor of this rotor as well as field will experience a force. Due to that force, the torque will be created, which will make the movement of this movement of this rotor, because this stator is fixed one. The winding in the stator is fixed. So you cannot, the force cannot make movement of this one. So that will make the movement of this rotor. So that's why we can say stator of the conductor is stationary part and rotor is the rotating part. Rotor is the rotating part. So AC currents reverse direction, that's why it is called as alternating current, and the two parts, stator and rotor, stator stationary components and rotor rotating component. And we have in AC motors, we have the two different type of motors. In AC motors we have the two different types of motors. One is called the synchronous motor, another one is called the induction motor. There are two type of AC motors. There are two type of AC motor, synchronous motor and induction motor. Synchronous motor also will be require the AC supply, and induction motor also will be require the AC supply. So, but the working principle of the both will be different. The working principle of the both will be different, and but the major parts available or used will be remaining same, because both the machine will have the two type of winding. There is no difference. Both the motor, synchronous motor as well as induction motor, both will have the stator winding and rotor winding, but its working, its construction will be different in such a way that the performance or its operations will be differ from each other. So that's why we have the synchronous motor and induction motor. So if you see that here the different parts has been shown in a larger way, the stator winding and rotor winding, and the enclosure has been shown here, and you can say there will be a air gap between stator and rotor, because the rotor outer frame and inside the rotor outer frame the stator winding is there. So there should be a air gap between stator and rotor, so that the rotation will be there, right? And it is of the outer frame. So parts of AC motor means here it been shown with the complete cut model. This is a cut model of the machine where the stator has been shown and the rotor is here, and the bearing arrangement will be, because which rotating will have the rotation, the bearing is always required. Wherever the rotation is there, the bearing will be used in order to have the proper frictions, and also cooling fan also will be provided, because the current will be carried by the conductor. Current will be carried by the conductor, where the heat also energy will, because the conductor will have the small resistance, so in the resistance the current flowing, the voltage drop will be there, where the energy conversion will be there, though some losses will be there, so heat also will be produced. So that heat has to be compensated. So for that purpose, the cooling fan also will be available, bearings will be there in the both ends, and it's your outer frame and end bracket to bearing housing. That means how we have to hold the bearing here, so for that the bearing house has been available. So it is nothing but a cut model. It is nothing but a cut model of the AC motor. Stator winding, rotor winding, bearing setup, and outer main frame structure, the cooling fan, and the bearing available, and the bearing housing. Bearing housing means the setup which have to hold the bearing, right? So this is the major part of the AC motor. AC motor, so I have said that we have the two different AC motors, synchronous motor and induction motor. So induction motor, first we discuss about the induction motor. Induction motor, most common motors in industry. If you see the application of the induction motor, it is unlimited. Wherever you found the domestic application, industrial applications, we will find the induction motor in many cases. In an industries, you will have the performing the mechanical production unit or control unit, or even in home mixie grinders. For on fan also, in fan we are using the single phase induction motor. So we may be knowing about the single phase and three phase, because in case of AC we have the two type of different supplies. One is the single phase AC supply, another one is the three phase AC supply. The house, small power rating houses will normally have the single phase AC supply, so single phase motor and three phase motor. So in induction motor we have the single phase motor as well as three phase motor. So three phase motor will be used in the high power applications. Small power applications we use in the single phase motor, because you cannot make a single phase with a larger power capacity. So that will make a difficulty in running the machine, construction of the machine. That's why we have the three phase induction motor. So advantage of the induction motor is simple design, inexpensive, high power to weight ratio, easy to maintain, direct connection to AC power sources. Direct connection to AC power sources, they are the some of the advantages why we are using this induction motor in the many field applications. Now you see how this induction motor works. The induction motor is working principle, basically the same thing, Faraday's law. So when you are going to discuss about the induction motor, how it is working, you have to recall the transformer, because normally the transformer is being discussed in the electrical machine 1. So there normally the transformer working principle explained. The transformer is working based on the induction principle with mutual induction. The same manner the induction motor also works. In transformer we say primary winding and secondary winding. In transformer we say primary winding and secondary winding, but here we say stator winding and rotor winding. Here we say stator winding and rotor winding. So in transformer, how we give the supply? We give the supply to the primary winding. The winding to which supply is given is called as the primary winding. So when you are giving supply to the primary winding, the primary current will flow through the primary winding and it will establish the EMF in the primary winding according to Faraday's law. So similarly, the same flux will also go to the secondary winding. The same flux will also go to the secondary winding in transformer. Similar way in this induction motor, the supply will be given to the stator winding. Supply will be given to the stator winding. We will not going to give any supply to the rotor winding, but the supply will be given to the stator winding. So when you are giving supply to the stator winding, your rotor is inside the stator. Your rotor is inside the stator, that already we have shown in the construction, right? We have shown in the construction. See, this is your stator. The stator is covered, and inside we have the rotor, right? So supply will be given to the stator winding. Yes. So when you are giving supply to stator winding, there will be a stator current flow. There will be a stator current flow. That stator current will make the EMF induced in the stator winding. Although the stator current will also link to your rotor conductor. Stator current will produce the rotating magnetic flux that will also link your rotor conductor. The way how in the transformer the flux which is produced in the primary winding current also will link the secondary winding. Similar way in the induction motor, the current flow through the stator winding, will produce the magnetic flux which also will link your rotor winding, and hence the EMF also will produced in the rotor winding according to Faraday's law. The Faraday's law, what it is saying, if the change in flux cut the conductor. If the change in flux, we are supplying the alternating current. So alternating current will produce the alternating flux. That alternating flux will be linking the conductor. So it will cut the conductor. So when the flux cut the conductor, according to Faraday's law, EMF induced. So in this case, the EMF will be induced in your stator winding. Also the EMF will be induced in the rotor winding because of the flux produced by the stator current. So when the EMF induced in the rotor winding, there will be a current flow, because normally in the construction the rotor winding of the induction motor is closed one. So we were aware that in a closed path the current will flow through. So when the EMF induced in the rotor winding and the circuit is closed, because of the conductors are closed, so automatically there will be a current flow in the rotor. So when the current flow in the rotor, now there will be a magnetic field produced by the rotor current as well as stator current. So now, due to the interaction of the magnetic flux of the rotor as well as stator, there will be a force is experienced by the conductor. That force will make the turning of or rotation of this rotor. So the rotor will start to rotate. So now the rotor will be rotating at a speed. So that is called as the motor speed. That speed will be lesser than the rotation of the magnetic field of your stator. This is the only the difference between the transformer and induction motor. In transformer, EMF induced in the primary winding and the secondary winding will be same frequency, but in case of induction motor, the EMF induced in the rotor and the stator will be different after the rotor start to rotate, because the rotating magnetic field, which is nothing but the synchronous speed, it is called as synchronous speed, which will be rotating this stator, that will go for your rotor. So rotor also will be having the same frequency till the rotor is start to rotate. Once this rotor start to rotate, there will be a different frequency of this rotor, because both cannot be run at the same speed. That's why it is called as a induction motor. Induction principle, EMF induced in the rotor due to the stator, this machine is working. So it cannot run at the same speed. The induction motor cannot be run at the same speed with your stator field, and rotor speed cannot be same. But the rotor will be rotating at a speed lesser than the stator. And under the running condition, the rotor will have the different frequency. The rotor will not have the fundamental supply frequency. That is the major difference between the transformer and this induction motor. In transformer there is no rotating part. That's why the EMF induced and also the frequency of the primary winding and the secondary winding will be remaining same, but the frequency of the stator winding will not be equal to rotor winding in the induction motor, but it will be different according to the rotor rotation conditions, and both will not run at same speed. Both means here the stator side magnetic field, rotor side rotor rotation. The stator field will be rotating at the synchronous speed, but the rotor between actual speed of the motor will be lesser than the synchronous speed. That's why it is called as the induction motor, because it is the used or the EMF induced principle is used. That's why it is called the induction motor. Induction means EMF induced in a rotor due to the stator current. That's all. So electricity supplied to the stator, right? What I have said, that is written here, right? And magnetic field generated that moves around the rotor, right? Current induced in the rotor. What I have said is being said here, right? The rotor produces second magnetic field that opposes stator magnetic field. Rotor begins to rotate. So very simple step it has been said. That means the supply given to the stator current will flow. It will produce magnetic field that will also link your rotor. Then rotor current flow, because rotor circuit closed. Then rotor EMF also induced and rotor magnetic field also produced. So this produced field and this field will interact each others, and hence the rotor will get the force. Rotor conductor will get the or experience the force, which will turn make rotate of the rotor. Simple steps of the working principle explanation. Electricity supplied to stator, magnetic field generated that move around the rotor, current induced in rotor, rotor produce second magnetic field that oppose the stator magnetic field, and the rotor begins to rotate. This is a very simple way the working of the same thing has been shown here, right? Yes. So types of, this is the type of induction motor. One is called as the shaded pole motor. So basic construction we have seen, and types of induction motor we have seen, and this is the what are the different type of induction motor has been shown here. The shaded pole induction motor. Shaded pole induction motor. The shaded pole display the creation of the magnetic field in the portion of the stator poles. Actually, the shaded pole means, actually what is pole? Pole we have known that a pole is used to place the field winding. Pole is used to place the field winding, right? So field winding is for what purpose? In order to get the magnetic field to be produced. So the shaded pole delays the creation of the magnetic field in that portion of the stator poles. This produces a magnetic field in the shaded portion that is approximately 90% apart from the magnetic field produced in the main portion of the pole. It means that actually there will be a n number of poles. The machine may be 2-pole machine or 4-pole machine or 8-pole machine we can have. To some poles we will make the shadow this is used in order to reduce or in order to create the magnetic flux difference between the main field as well as the shaded pole. So that the difference, so that the rotation difference between the stator field and rotor field can be created, because in induction motor we need to have the rotational difference between the rotor speed and the stator field. So this is one type of creations with the help of the shaded pole. A non-reversible motor. Non-reversible motor means you cannot run in the both the directions. It can run only in the one direction. This is pole piece and shading coil. There are one particular portions to make a difference in the magnetic field. This shading is used. And another type is induction motor. We are using the capacitor. The three types of capacitor start induction motor. We are using capacitors to start the induction motor in different way. Capacitor start disconnection, capacitor after motor speed pickups. So that is one category. Actually, we may be seeing the capacitors, for example, in fan. In fan, one capacitor will be there. Normally we call it as a conductor. So that capacitor main purpose is to make the induction motor self-starting. The single phase induction motor, to make the self-starting, this capacitor is used. So once the motor is started, if you remove the capacitor, still this will be running. So you can check it by our side easily. So once the fan is started to rotate, you can remove the capacitor. You will not find the fan will be stopped. It will be keep on running. So that is one category, that the capacitor start motors. To support the start means the capacitor only used just for starting purpose. After that, there is no need of capacitor, you can remove it. And another one is capacitor run. Capacitor run means to after the motor running, still the capacitor will be kept there. So keep the capacitor connected during the operation of the motor in order to keep the electric power consumption low. The actual, as an electrical engineer, we are aware that the capacitor will save the energy and it will produce the leading current. It will produce the leading current. We are aware about the power factor. Power factor, what is power factor? Power factor, we have three different categories. We have the three different loads: resistive load, capacitive load, inductive load. So in resistive load we have the pure unity capacitor, unity power factor, and in induction lagging power factor, and capacitor leading power factor, leading current. So leading current capacitor will provide the induction motor. It is a lagging motor. The current will be lagging. So to compensate that lagging current, we can keep the capacitor under the running conditions. That will be giving benefit. That's what we are saying, that why we are keeping the capacitor. Keep the capacitor connected during the operation of the motor in order to keep the electric power consumption low. Power consumption low, in the sense you can say, to provide the leading current to the motor, to compensate the lagging current in the induction motor, we can keep the capacitor under running condition as well. And capacitor start run. Third one is capacitor start run. Use two capacitors. One for starting and one for running. This further improves the power consumption. With how many capacitors you are using, accordingly your machine performance will be improved, because the capacitor is providing leading current which will improve the power factor. We were aware about the power factor improvement, because in AC power the power factor playing important role. What is power factor? What is power factor? Power factor is nothing but the phase angle between rotor and phase angle between voltage and current. So phase angle between voltage and current, if current is lagging to the voltage, their losses will be there. So their losses will no benefit, because losses means efficiency will be reduced. So that's why the power factor need to be improved, and there the capacitor is playing important role. So we can have three different type of capacitors used in the induction motor. Based on that, we can have the induction motor name. Induction motor name, previously we have said shading pole. shading pole induction motor, that is one. And when you are using the capacitor for the induction motor, so there you can get capacitor start motor, capacitor run motor, capacitor start run motor. So these are the three different induction motors based on the use of the capacitor. So capacitor start means after the starting the motor you can disconnect the capacitor. Capacitor run means after motor running still this capacitor will be remaining present in the system, in the motor. And the capacitor start and run cases we will be using the two capacitors. We will be using the two capacitors, one for the running and another one for the starting. So at the time of starting one capacitor will be used, and after the started to running another capacitor will be used. So both the capacitor will be playing important role improving the power factor, because we know power factor less will make the more losses. The start circuits have centrifugal force. The circuits, what are the circuits will be having? You can see running winding, so start winding, start capacitor, this is producing high starting torque, centrifugal switch, and running winding, reverse direction of the rotation by interchanging the running winding or starting winding connections. Actually we have said two things, two winding names, stator winding and rotor winding, but when we come to use of the capacitor cases where we say start winding and run winding. The start winding means it is main winding, it is a main winding, that is starting winding, and running winding means which is you are using the capacitor shading, they are the running winding. So this cases the reverse directions, actually the direction of the motor rotation clockwise or anti-clockwise can be made with the help of the reversing the direction of the rotation. Direction of rotation, motor rotation can be done by interchanging the running winding or starting winding connections. Normally starting winding connections are preferred because supply terminal which is connected to the starting winding, you can indulge the supply terminal, easily the motor direction can be changed. So motor direction can be easily changed by indulging the supply terminals. By interchanging the supply terminals. This is the diagrams where we are showing starting winding, that is its main winding, starting winding, it's your rotor, right? It's your rotor. So main winding is there and the starting winding is there. You can indulge in starting winding connections or supply winding so that up to directions of the motor can be changed. Capacitors also used, capacitor used. Yes. Capacitor run cases, running winding, reversing the same thing. Diagram is like this. This is the AC supply we are giving, capacitor run capacitor, this is a running winding and this is a starting winding, right? The diagram for the capacitor run motor. The operation is remaining same. Yes, this is the typical capacitor start run induction motor. Capacitor start induction motor, we have the two capacitors. As I have told you, we have the two capacitors. One centrifugal switch also will be there. At the starting it will be here, at the running this will be connected, right? So input power, main winding, starting winding and rotor winding is there. Yes. Yes. See input. You can say I have said the word poles. We have using two windings, field winding and rotor winding, or field winding and armature winding. So field winding is placed in the pole. So poles winding which produce the magnetic field necessary to have the rotor to run. So that poles means what? This is the north and south pole, where the field winding will be placed. Field winding will be placed, which will make the rotor to rotate, because Faraday's law. What is the Faraday's law? According to the Faraday's law, the conductor is placed in the magnetic field. So the magnetic field is created by the field winding. The field winding will be placed in the pole. Field winding will be placed in the pole. They are the poles here which the field winding has been placed and the magnetic field is created. So this is rotating. Conductor is rotating. So you can say here, this 3-phase 2-pole motor. 3-phase means, I have told you, in case of induction motor or in case of AC motors, we can have the 3-phase and 2-phase. We can have 3-phase and 2-phase. The 3-phase machine means 3-phase supply. RYB, like the 3-phase supply will be taken. The 2-pole means the poles will be of 2. The poles will be of 2. So you can say north south, north south. So field winding placed in this poles. So that's why this is called as a pole. This is called as a pole. And it will be created. Here we have the 6 poles. 1, 2, 3, 4, 5, 6. Why we have 6 poles? 2 poles per phase. 2 poles per phase. So 3 phase, that's why it having the 6 poles. 1 pole for one phase, another pole for another phase, another pole for another phase. So we are having the 2-pole motor and 3-phase supply. That's why we have the 6 poles here. And the conductor placed will be of 120 degree to each other. The conductor placed in the 120 degree from each other. So you can say this is the one pole. A1, A2 is of the one phase. B1, B2 is another phase. C1, C2 is the another phase. So like that, they will be placed in the like this positions where the electrical degrees, because total is 360. Total is 360. Right, inside the coil 360 will be there, but the coil will be divided into in such a way that they will have the 120 degree difference between each and every phases. So this is the one terminal and this opposite terminal of the same phase. This is the one terminal and opposite of another phase. The one terminal and opposite of another terminal. So the totally each terminal will have the 120 degree phase difference in a 3-phase system. And synchronous motor. So far we have seen about the induction motor. So induction motor, we say that it will run at a speed lesser than the synchronous speed. So but synchronous motor will run at a particular speed. At a particular speed means synchronous speed. The speed of the stator rotating magnetic and rotor speed will be remaining same. We have to run, the machine can only run at a particular speed. At a particular speed means it can run at a particular speed, a common speed. It cannot have different speed. It cannot have different speed. But it is not so in case of induction motor, because induction motor can have any kind of speed, but it cannot run at synchronous speed. But in synchronous motor can only run at a synchronous speed. On other speed it cannot run. So require DC voltage for starting excitations. Here one difference between synchronous motor and induction motor, where induction motor there will be no separate any DC excitations, but the synchronous motor will be requiring slow starting torque. Starting torque will be low, and the rotor of the synchronous motor travels at the same speed as rotating magnetic field. This is the word we have to keep remember, because the synchronous motor, synchronous means synchronization between stator magnetic field and rotor should be run at a same speed. So magnetic logging will be occur between the stator magnetic field and rotor at a particular speed. That is called as synchronous speed. So it is called as synchronous means synchronous motor will run at a single one speed only, no other speed. Rotor with a single winding, slip ring brushes and 3-phase stator winding. So additionally we will have the rotor winding with the single phase, and 3-phase AC winding will be the, and slip rings and brush arrangements additionally will be used in the synchronous motor. You can see that field winding, and inside this is armature winding, which is rotating winding, which is connected to shaft, and we have the brush assembly here. So slip ring, this is slip ring which will be rotating and it will be collecting current, or it will be sending current, right? So 3 terminal, 1, 2, 3, 3-phase winding, so 3 terminal, 1 and 2 and 3 terminals. So inside we will have a single coil for the rotor, and for the collection of the current or mechanical output, this slip ring arrangement and brush arrangements have been put up. Brush will have the continuous touch with this slip ring arrangement. The shaft will be molded with your rotor winding. Synchronous motor, 3-phase motor, right? As I said that it will be running at a constant speed. So constant speed fixed by the system frequency, used where there is a need to improve the power factor. The application of synchronous motor is used for the power factor improvement. So previously I have said power factor corrections. Power factor improvement is required. Low power factor will lead to increase more losses. So we also using capacitor. So in case of where the capacitor is not available, we can use the synchronous motor by which you can improve the power factor. The synchronous speed is normally calculated by 120 F5P. The synchronous speed of the machine can be calculated with the help of the NS equal to 120 F5P, where 120 is constant, F is nothing but the supply frequency, and P is nothing but the number of poles. How many number of poles we are using, accordingly the speed, synchronous speed will be defined. So there are two parameters. Which will be defined the speed of the machine, synchronous speed. If you want to change a particular speed, you can change the P or you can change the F. With these two parameters, the speed can be changed to a next value. Suppose the synchronous motor can run at a different speed. For example, for the number of pole, 2-pole machine at 50 Hz, it will run 3000 RPM. At 60 Hz, 3600 RPM. The 4-pole machines can run to number of poles increasing, the speed will be keep on reducing. Number of poles increasing, the speed will be reducing, because they have the inverse relation. Synchronous speed and number of poles usage is inverse relation. That's why if the number of poles increase, the speed will become reduced. So this is what the diagram. Each AC phase have the 4 stator winding. Each winding is opposite direction from the proceedings, opposite directions, and field strength rotates with the AC current of the each phase. The field will be supported because the motor you have to give supply to the stator as well as rotor. So the AC source will be connected to the stator winding. 3 types of induction motor: 3-phase supply producing magnetic field, stool gauge or wound rotor, self-starting, high power applications, factorial to 100 horsepower applications, pumps, compressors, conveyors, belt, grinders. 70% of motor is in industries, right? Asynchronous motor, induction motor is only called the induction motor. AC motor is common from all asynchronous motor because it is not running at a synchronous speed. It's basically an AC transformer with a rotating secondary. You can say the induction motor, which simply you can say it is like a transformer, but the secondary is rotating. That's all. Components: rotor, spool gauge, conducting bars in parallel slots, wound rotor, 3-phase, double layer, distributor winding, Actually, this is the components I have already said, rotor and stator. But in the rotor for the induction motor, it can have the two different connections. One is full gauge, another one is wound rotor. In construction of the rotor of the induction motor, two different types. So rotor construction, based on that, the induction motor can have the two types. One is full gauge, another one is the wound rotor. In full gauge, the conducting bars will be used in parallel the slots, and wound rotor, 3-phase double layer distributor winding will be used. You can say that. So it will be rotating like this. Flux stator field produce the rotor's induction field. Arrow shows stator magnetic field vector. This arrow showing that magnetic field, how the magnetic field is vary, and due to that magnetic field linking your rotor, it also rotates. So stator magnetic field need to be given supply. So stator field also will have some phase angle difference according to its magnetic strength. Magnetic availability to the rotor from pole to pole will be different. Three different phases will be there, and the rotor there is no phases, single conductor winding will be used. And if you want to interchange the directions, if you want to rotate the induction motor in any of the direction, clockwise to anti-clockwise or anti-clockwise direct clockwise, just you interchange the two terminals. Outside 3-phase supply you are giving to the stator, so interchange the supply terminal, the motor rotating magnetic field direction will reverse, so automatically motor speed will be also reversed. Motor field also will be reversed. Like that, you can change the interchanging the stator winding. So just you interchange the terminals so that you can interchange any two terminals. You change this two in the terminal, or this two, or here this two, right? So three different examples we have show. The rotation of the induction motor direction can be reversed by interchanging the any two terminal supply terminal. So suppose it's A, B, C, so interchange A and B, and here B and C, and here you can change A and C. So three examples have been reversing for the 3-phase induction motor. Voltage Hertz ratio. Voltage Hertz ratio means it's we need to change the speed. Suppose you want to change the speed, you have to maintain the voltage and frequency relations, same ratio. Value can be changed, voltage value and Hertz value can be changed. Value of the voltage different and value of the frequency different, but its ratio need to be remaining same. In such cases, you can have the different speed of the motor. For a synchronous motor rated for 3-phase 460 volt 60 Hz at this RPM, what will be the operating frequency and the voltage if the motor controller commands the motor to run 750 RPM. So voltage ratio you should calculate like this. How much it's 7.67. NS corresponding speed will be like this. Corresponding speed will be like this. 2-pole machine. So you can say 2 equal to this much. So 45.83 Hertz. Voltage ratio this one. Frequency will be this one. So automatically you can get this much voltage will be there. This much voltage will be there for a synchronous motor rated for 3-phase. 3-phase motor 460 volt applied and 60 Hz, it is running at 3600 RPM. What will be the operating frequency and voltage if the motor controller commands the motor to run at 2750 RPM? 2750 RPM. So we need to take voltage frequency ratio, voltage applied 460, frequency 60, so ratio 7.67, and synchronous speed we have ns equal to 120 f5p to frequency 60, and the number of this speed, synchronous speed they have say 3600, so this is 600, so we are getting the p equal to 2 poles available. So now ns equal to 120 f5p, so substitute the values, you will get the frequency, and substitute the values here, the frequency value, the voltage will be available. So the corresponding frequency and the voltage will be this much. Frequency will become 45.83 Hertz and voltage will become 351.52 volts. This is the determination of the voltage frequency values to maintain the voltage frequency ratio. If you consider for the school gauge induction motor, rotor stator will be there like this. It will have the construction like this: stator winding, one for one phase and another phase and another phase. It means A and A dash for one phase, B and B dash for another phase, C and C dash for another phase. So you will have the three terminals out. This is for the stator. Rotor, this is the rotor representation. This outer frame, stator, because this is diagram of the circuit diagram, right? Circuit diagram. Earlier we have seen the winding diagram. It's a circuit diagram where the connection house given. Outer frame, stator will have the three-phase winding, and the rotor will have the single rotor construction conductor. They all are the conductors, closed conductors will be there. Oh, that is nothing but your rotor. Here, slip and speed. Motor never run at synchronous speed. Induction motor never run at synchronous speed, but lower actual rotor speed. Right? Difference is slip. That means induction motor is not going to run at a synchronous speed. So there will be a difference between stator speed and rotor speed. That is called as the slip. So ns minus nr by ns into 100. So ns is synchronous speed in RPM, nr is the rotor speed in RPM. So the difference is called as a slip in the motor. The rotor contain, you can see, field three-phase rotor winding, field winding, brush assembly for three-phase system, slip ring and brush provide an electrical connection to the rotor winding. The rotor winding, the three-phase slip ring and brush assembly have been given. Slip ring and brush assembly provide the electrical connection to the rotor winding. This is your rotor winding. The wound rotor induction motor is considered to be a variable speed motor. This can be considered a variable speed motor because you can change the voltage frequency so that the speed of the motor can be changed. Initial cost of the high and the maintenance cost is high than for school gauge induction motor. Compared to the wound rotor cases, school gauge induction motor, the initial cost is high and maintenance cost is high than for a school gauge induction motor. If you consider the comparison with the wound rotor machine with your school gauge, previous is school gauge. Which is school gauge? This is school gauge. This is school gauge. Right. Here rotor single winding, stator three winding, but in wound rotor, this is wound rotor. In wound rotor, we will be having three-phase winding for rotor as well as three-phase winding for stator. So stator also will have three-phase winding, rotor also will have three-phase winding. So that's why the construction point of view, requirement of the material point of view, the huge amount has to be spent for the wound rotor cases. That's why the cost is high. Initial cost is also high and the maintenance cost also high for the wound rotor machine than the school gauge induction machine. Right. Yes. Okay. So let us to summarize the presentations. We have discussed the AC motors. AC motors will have two winding, stator winding and rotor winding. Stator winding, stationary winding, rotor winding, rotating winding. And in AC motor we can have the single phase motor, three phase motor. Right. In single phase motor also we had some further classification: capacitor start, capacitor run, capacitor start run, and shaded pole. That four coming under the single phase. When you come to the three phase, we have the slip ring induction motor and synchronous induction motor, slip ring screw gauge induction motor. Synchronous motor will run at a synchronous speed, and induction motor will at the speed lesser than the synchronous speed. In induction motor we have the screw gauge and wound rotor. Screw gauge, three phase AC winding for the stator, and there is single winding for the rotor. But in case of wound rotor, we have the three phase for the stator winding as well as three phase for the rotor winding. So accordingly the classification was there, and working of the machine is remaining same. In induction motor, whether it is a slip ring or wound rotor, the working is remaining same only. Right, synchronous motor, the same thing, it will run at a synchronous speed with constant speed motor. So it can be used for the power factor improvement, like that we have discussed. So in this class we have discussed about the different type of AC motor available and its working principle. We have discussed. In the coming classes we can go for the its performance operations, how the characteristics operations we will be discussing. Thank you.